Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE Math October-November series 2019 paper 21. And what we're going to do is look through worked solutions for this IGCSE test in hour and 30 minutes. And again, focus on how to identify the problem, how to set it up, how to solve it, and make sure that you can think through those steps on your own. It'd be good if it'd be good that you first try it yourself. And then if you get stuck, watch the video and then try to do it yourself. But make sure that you can do it independently and think through it on your own. So let's get started here. And here we see, sorry, it's a little bit blurry. It says work out 5% of $25. So 5% as a decimal is 0.05 times 25 is 1.25. Pretty easy there. Factorize, whenever you factorize, you look first of all what's common to all the terms. There is a P common to both terms, so we factor that out. Remember, factoring is dividing, but you divide it to the front. And then what's left over, 5p divided by p is 5, pt divided by p is t, so you get 5 plus t in the parentheses, and so you end up with p times 5 plus t is your factorization. Calculate, and this is 16.379 minus 0.879 divided by 4.2 times 1.241. Give your answer correct to two significant figures. This is just checking to see that you can enter it into your calculator correctly. Notice you have this multiply here and this divide. You need to put this top part of the division in parentheses so that your calculator knows that this subtraction needs done first before you divide. Divide and multiply actually can be in either order, but you need to make sure that this top part of your fraction is in parentheses when you enter it into your calculator. You get 4.5798, and it says to two significant figures. So the 4 would be the first and 5 is the second. You look at the number after it, which is 7. It's 5 or greater, so it's going to round this up, and you're going to get 4.6. Write 15,060 in words. So you should recognize that as 15,060. So when you write it, you put 15,060. And then in standard form or scientific notation, you're going to move the decimal all the way up until there's only one number in front of the decimal. You're only allowed to have one number or one digit in front of the decimal for scientific notation. So notice you moved it over 1, 2, 3, 4 places. So you get 1.506 times 10 to the 4th power. Here's simplified. This is just adding like terms. So you have 5c minus 2c and a negative d minus 3d. So you end up with 3c minus 4d in the simplified form. Here's a solving. Here you have x minus 2 over 3 equals 3. Want to clear the fraction, so multiply both sides by 3 to get rid of this fraction here. So that gives you x minus 2 equals 9. Add 2 to both sides, you get x equals 11. That was pretty easy. Here's a simplify using exponent rules. So the coefficients is your basic math part, so you just get 2 times 3, so you get 6 as your coefficient. Then for the variable and exponent, when you multiply like bases, you add exponents. So 3 plus 2, it gives you x to the 5th power. So you end up with 6x to the 5th. Without using a calculator, work out 5/16 times 1 and 1/7. So we're going to change the mixed number into an improper fraction. So 1 times 7 is 7 plus 1 is 8. So we get 8/7. It is multiply. So that means the numerator and denominators can cancel. So the 8 and 16 cancel to 1/2. So 5 times 1 is 5. 2 times 7 is 14. So we end up with 5/14. Here is a simple interest. Notice this is simple interest. So Paula invests $600 at a rate of R% per year, simple interest. At the end of 10 years, the total interest earned is $90. Find the value of R. So our simple interest formula is I equals PRT, I being the interest, 90 equals P, the principal, that's 600. R, and then T, the amount of time, 10 years. So we end up with R equals 90 divided by 10 times 600. All of this comes out to 0.015. We want our rate as a percent. So move the decimal over twice and you get 1.5%. Simplify x cubed over 8 raised to the negative 4/3 power. So what I'm going to do is I'm going to take that negative first and distribute it to the parentheses. So what that negative is going to do is it's going to flip everything in the parenthesis upside down. So it becomes 8 over x cubed to the positive 4/3 power. And now I'm going to distribute the 4/3 exponents distribute to multiply or divide. So since this is a division, becomes 8 to the 4/3 power over x cubed to the 4/3 power. So in the numerator, remember on a fractional exponent, the bottom number is a root. So the cube root of 8 is 2, and then the top number is an exponent. So 2 to the 4th power is then 16, or you can just do it on your calculator, but you should be able to do it in your head. Cube root of 8 is 2, 2 to the 4th is 16. On the bottom, when you raise an exponent to an exponent, you multiply. So the 3's cancel and you're left with x to the 4. So our final answer is 16 over x to the 4th power. Here we want to rearrange the formula to write r in terms of p and pi. So we want to make r the subject. So what we're going to do is we're going to factor the r out here, and we're on the right hand side. So we divide it out or factor it out to the front, and then that leaves 2 plus pi in the parentheses. Since we're solving for r, we're going to divide that 2 plus pi to the other side. So r equals p over 2 plus pi, which is our answer. Now we have an upper or lower bound type question. Remember, with upper and lower bound questions, there are generally 2 layers. The first layer is with your measured value itself, and then the second layer is with the formula. So for the first layer, we need to find our upper and lower bound for our measured value, and notice it's correct to 1 decimal place. It's not correct to the ones, it's correct to 1 decimal. So if we divide 1 decimal in half, that gives us 0.05. So if we go down 0.05, that takes us to 15.05. If we go up 0.05, that takes us to 15.15. So this is the upper and lower bound for the measured value. Now we want to figure out which one of these we use in the formula. The formula wants to find the upper bound for area. Well, area of a square is A equals S squared. So if you want the upper bound, then of course we're going to want to use the bigger number. When you square the bigger number, you're going to get your maximum area value. So 15.15 squared gives 229.5225. Be careful with this. A lot of students get in the habit of doing the 3 significant figures, but 3 significant figures is only for irrational numbers when your decimals run off your calculator. Here the decimal stops. Even though it goes 4 decimal places, it does stop, meaning this is an exact value. So you should put the entire exact value down. Don't round this to 3 significant figures because this is not an irrational number. It is an exact number. So be careful with that one. Here, number 13 is a triangle. It wants us to calculate the area of a triangle. Now, a lot of students will think half base times height, your geometric formula, but it's a little difficult to figure out the height from this. So it's a little easier if you use the trigonometric formula for area of a triangle, which is 1/2 AB sine C. As long as you have two sides and the included angle, then you can use 1/2 AB sine C. So here you have 1/2, A is 11, B is 13, and sine of the included angle, sine of 39 degrees. Make sure your calculator is in degree mode when you calculate this out. You get 44.996, because this is all multiply here. And to three significant figures, I just ended the numbers at 996, but they do continue on. So to three, actually, when you're doing, why did I put degrees there? Sorry, that should not be degrees. You go three significant figures. And so notice 1, 2, 3. The next number after that is a 9. So that's going to raise this up to 50. You do need to put the 0. It is 45.0. Should not have the degree. We're not have a, it's area, it's not degrees. So sorry about that. Scratch off the degree. Don't put the degree symbol there. It's just 45.0. And this page is quite blurry, so sorry for the quality of the when I scanned it. And the scale of the map is 1 to 10 million. 10 million is 1 followed by 7 zeros. Notice it says on the map the area of Slovakia is 4.9 centimeters squared. So we're going from linear to area, so we need to do that first. Remember, with these kind of problems, there's pretty much three different things you're going to have to keep track of. One is the scale itself. Two is the dimension that you change into. In other words, in here, it's linear to area. And the third thing is your units. So here is our scale, 1 to 10 million, which is 10 to the 1 or 1 times 10 to the 7th power. Then we want to change it to area, so it's two-dimensional. So we're going to square it, square the 1 over 10 million, and we get 1 to 1 times 10 to the 14th. So our 1 times 10 to the 7th, when you square it, becomes 1 times 10 to the 14th. I probably could have showed that a little bit so you could follow it more easier, but it'd be 1 over 1 times 10 to the 7th squared. So 1 squared is 1, and 1 times 10 to the 7th, you just multiply the 7 by 2 and get 14. So this is our ratio for area. Now we need to set up our proportion. And we have 4.9 centimeters square, that's obviously on the map, to an actual area equals a 1 to 1 times 10 to the 14th of map to actual area. Cross multiply, so our actual area is 1 times 10 to the 14 times 4.9. That puts us in centimeters square for actual area, and we want the answer in square kilometers. So centimeters square, there's 100 centimeters in a meter. Again, this is linear, so we need to square it to make it area. And then 1,000 meters to 1 kilometer. And then, of course, we square that. And that gives us 49,000 square kilometers, which is our answer after you multiply all this across the top and divide by this across the bottom. Pay attention to this. These squares do apply to the bottom. So it's actually a 100 squared and a 1,000 square in the denominator. And all of this comes out to 49,000 square kilometers. Here on number 15, we have an inversely square. I know it's difficult to read. It's y equals, or y is inversely proportional to x squared. So when you set it up inversely proportional, you divide the proportionality constant, which you have to provide, by what follows, in this case, the x squared. If it were directly proportional, you would multiply. So inversely, you divide the proportionality constant by what follows. Directly, you multiply the proportionality constant by what follows. So this is inversely, which is divide k by x squared. Notice you don't see the k. You need to put the constant in because it's proportional. So we want to solve for that k first. So we plug in the 4 for x and the 2 for the y. So 4 squared is 16. 16 times 2 is 32. So our proportionality constant is 32. That doesn't change for the problem. That comes up here. Y equals 32 over x squared. Now we put in the new set of numbers. Find y when x is 1/2. So we put x is 1/2. 1/2 squared is 1/4. And when you divide by a fraction, you invert and multiply. So you get 32 times 4 is 128. Here, calculate the obtuse angle in this triangle. Well, when you have a non-90-degree triangle, you can use either law of sines or law of cosines. If you have a pair meaning a side with its corresponding angle or the angle across from it, then you'll use the law of sines. If you do not have a pair, that is, there's no side with its corresponding angle, then you would use the law of cosines. So since we have a pair that is a side in its corresponding angle, we can use the law of sines. So 8 over sine of 39 equals 12 over sine. And I just called it sine B, but it's actually this x here. And again, make sure your calculator is in degree mode. Cross multiply. So 8 times sine B equals 12 sine of 39. Then divide by the 8 to get the sine B by itself. And then we want to get the angle B here. So we inverse sine both sides. So the inverse sine of 12 sine 39 over 8. And when you do that on your calculator, you get 70.7 degrees. Remember with degrees, you want to go to 1 decimal point, so 70.7 degrees. Now, you should notice that 70.7 is an acute angle, and this is asking for the obtuse angle. So since your calculator gave you the acute angle, we need to do 180 minus 70.7. Remember, sine is positive in both the first and second quadrants. So your 70.7 would be the first quadrant answer, which is why your calculator gave you this. Your second quadrant answer, which is the other quadrant that sine is positive in, would be 180 minus that, which is 109.3 degrees. So notice the obtuse was in bold to help you remember that when you get this acute angle. Now this is much clearer. You scan here. Number 17, the diagram shows two sectors of circles with the same center. Calculate the shaded area. Well, of course, in these scans, the shaded area doesn't show up very well. This out here, this outer part is what is shaded. And so to find the shaded area, we need to take the area of this big sector minus the area of the small sector to get this outer part here. So remember, sector area is, and it gives us degrees. You have two sets of formulas with sector area. One is with degrees and one is with radians. So since they give us degrees as our angle, we need to use the degree formula. And so that is 45 out of 360 degrees times pi r squared. So what fraction of our circle, pi r squared is a circle, the fraction gives us the sector. And we use the 5 because we want to take the big sector minus the small sector. So the small sector is still 45 out of 360 as our fraction, but now it is pi r squared with the little radius of 3. And when you calculate both of those, you get 9.817 minus 3.534. And that subtraction gives you 6.28. Moving on, we want to come up with a common denominator to write this as a single fraction and then in simplest form. So our x over 2 needs an x plus 1 multiplied top and bottom, and then the 2x plus 4 over x plus 1 needs a factor of 2 top and bottom so that we get the common denominator of 2 times x plus 1. So for the 2 times x plus 1 on the bottom, it's just 2x plus 2. You don't actually have to multiply that out. You could leave it as a 2 times x plus 1 in the denominator. I did multiply it out and get 2x plus 2. In the numerator, we have to distribute x times x plus 1 is x squared plus x. We have this minus sign, which does need to distribute to the numerator over here. So be careful and put in parentheses this distribution here. 2 times 2x plus 4 is 4x plus 8. This negative does have to distribute. That's why I put that in parentheses. So that gives us a negative 4x minus 8. So here's our x squared. Here's our x minus 4x is negative 3x, and our minus 8, distribute the negative to make it negative 8, all over 2x plus 2. So this is our simplified fraction, x squared minus 3x minus 8 over 2x plus 2. Again, it would be okay if you left it as 2 times x plus 1 in the denominator. Number 19 is matrices. Now for the new 2020 syllabus series, you do not have to do matrices. It's not, matrices is no longer in the 2020 syllabus cycle. And as of this video, which is now in 2021, you still don't have to do matrices. But I'll go over it with you anyway in case you are interested. So with matrix multiplication, you multiply matrix M times matrix P. Matrix multiplication, the order does matter, so you do need to make sure you put M first and P second. And when you multiply matrices, you do row times column. So the first element in your row times the first element in the column, plus the second element in your row times the second element in your column. So 1 times 5 is 5, 2 times 7 is 14, 5 plus 14 is 19. And notice where your row and column intersect. Well, your first row times first column, your element goes right here. Then first row times second column, 1 times 6 is 6, 2 times 8 is 16, 6 and 16 add up to 22. That's first row, second column. So notice first row cross with second column puts the 22 right here. Then second row, first column, 3 times 5 is 15, 4 times 7 is 28. 15 plus 28 is your 43. That's second row, first column is the 43. And then for second row, second column, 3 times 6 is 18, 4 times 7 is 32, 18 plus 32 is 50. So those are the 4 elements of your matrix multiplication of MP, 19, 22, 43, and 50. Now find this looks like a absolute value, but what it is in matrices is the determinant. So the determinant of matrix M. So what you're going to do is the subtraction of your cross multiply, your diagonal multiply down minus your diagonal multiply up. So I just call it down minus up. So it's the multiplication of your diagonal down minus the multiplication of your diagonal up, down minus up. So you get 1 times 4 going down minus 3 times 2 going up. So 4 minus 6 is negative 2. Now here's a probability question. The probability that the school bus is late is 9/10. So your first tree diagram is late or not late with 9/10, and then that leaves not late with 1/10. Remember, each tree segment has to add up to 1. So 9/10 plus 1/10 is 10/10, which is 1. Then if the school bus is late, the probability that Seb travels on the bus is 15/16. So if late, then bus or not bus will be 15/16, and then that leaves 1/16 left over to make this tree part 1, add up to 1. And then if not late, if the bus is on time, which is not late, then the probability that Seb travels on the bus is 3/4. So taking the bus after not being late is 3/4 to 1/4. Remember, with tree diagrams, these branches don't have to be chronological. It could be in either order here, but I chose to start off with late, not late, because that's what they started off first here, and then put the bus or not bus next. So 3/4, then you have to have 1/4 to make this tree branch equal 1. And the question is asking, find the probability that Seb travels on a bus. So you're looking for all the pathways where Seb takes a bus. So that would be this one here, 9/10 times 15/16. What you do that on your calculator reduces to 27/32. And the other pathway where Seb takes a bus is 1/10 times 3/4. And that gives you 3/40. When you add those two together, it comes up to 147/160. Now for a transformation. So describe fully the transformation that maps T onto A. If you notice, you can just slide this down. So if it's a slide type, that's a translation. And so you call it translation. That's 1 point for that. And then you get 1 point for the column vector. Remember, your column vector is how far you translate it for the X and over how far you translate it for the Y. It's not a fraction, it's a column vector. And so from this corner here to the corresponding corner down here, we go back 1 on the X. That's why it's -1. And then down 1, 2, 3, 4, 5. So a -5 for the Y. You can start from any corner. You could start from this one, over 1, down 5, or start from this one, over 1, down 5, or start from this one, over 1, down 5. So that's described fully. You need the type of transformation. It's a translation, and you need the column vector. Then on the grid, reflect shape T in the line y equals x. So I put my line y equals x in here. Notice y equals x crosses at the origin with a slope of up 1/1. So this dotted line represents the y equals x. And you're going to reflect this over this line of symmetry. So what you want to do is count each vertex perpendicular to the line of symmetry, and then count the same distance over. Notice this corner on our object is already on the line of symmetry, so that means when you reflect it over, it will still remain on the line of symmetry for your image. So this dot stays right here. This vertex up here is a half a diagonal of a square away perpendicular from the line of symmetry. So then you go a half a diagonal the other side, and there's your dot here. If you come over here, notice if you go perpendicular, you are two square diagonals to the line of symmetry. So you go 2 on the other side. And here's your vertex. And then from this one, you are also 2 away from the line of symmetry. So you go 2 from the other side, and there's your vertex. So you get your 4 points and then draw in your image. Here is a rate problem. A pipe is completely full of water. Water flows through the pipe at a speed of 1.2 meters per second into a tank. The cross-section of the pipe has an area of 6 square centimeters. and calculate the number of liters of water flowing into the tank in 1 hour. Well, notice that our units are given in meters and in centimeters. So we need to decide which one we want to convert to. Notice our final answer wants to be liters. So the easiest way to convert to liters is through cubic centimeters. 1,000 cubic centimeters is 1 liter. So since we want to be in cubic centimeters, that means we want to change our meter into centimeters. So 1.2 meters per second. We want to take 1 meter is 100 centimeters. So we multiply this and that gives us 120 centimeters per second, which then we multiply by our area of 6 centimeters square, and that gives us 720 cubic centimeters per second. And we want to change this to hours. So 60 seconds to 1 minute, 60 minutes to 1 hour. That cancels off all of your units for the time, and that gives you 720 times 60 is times 60. So times 60 times 60 is 2,592,000 cubic centimeters. You can't see it there. It's cubic centimeters per 1 hour. And then just divide by 1,000 or get rid of these 3 zeros to convert from cubic centimeters to liter. So you have 2,592 liters is what is going through that tank or through the pipe into the tank in 1 hour time. Coming down here, we have a Venn diagram, but you don't actually see the diagram. So you're doing kind of a Venn diagram question from the elements without actually seeing the Venn diagram itself. So it says complete each of the following statements. It wants A intersect B. So if you look at the group A with the group B, the intersect means the things they have in common. Well, they both have a 2 and they both have a 5. So 2 and 5 are the common elements of A intersect B. Then NB means how many. N is the number of items in group B. So we have 3 items in group B. Now we have to fill in the blank here for these other groups, 0, 4, and 6. So what is the relationship of 0, 4, and 6? Notice 0, 4, and 6 is in A, and none of them are in B. So that's going to be A intersect not B. It's in A and intersecting with it's not in B. Then we have 2, 4. We see that 2, 4, while there is a 2 for both A and B, we see that 2, 4 is both of them within A. So what you can use is a subset. That's not the letter C. It's a little kind of sideways U shape, and that means a subset of A. So 2, 4 is a subset of A. So again, that is not the letter C. I suppose I could have made it a little bit longer. That is the subset symbol, which is this symbol right here, but going sideways instead of downwards. Now we get to functions. Function of f of x is equal to 3x minus 5. G of x is equal to raised to the x power. Find f of g of 3. This is a composite function. So with a composite function, which means you have a function within a function, you take the number, evaluate it for g first, then you plug that answer into f. So 3 into g. So when we put 3 into g of x, we get 2 cubed, which equals 8. Now we're going to take that value, 8, and put it into the f function. So f of 8 equals 3 times 8 minus 5. 24 minus 5 is 19. Now find this symbol here is the inverse function of f of x. So find the inverse of f of x. So to find the inverse, you start with your 3x minus 5. I changed the f of x to y, and then switch x and y. Switch your x and y, so y becomes x becomes y. Switch x and y, and then solve for y, or make y the subject. So add 5 to both sides, divide by 3, so y equals x plus 5 over 3, and then change your y back into function notation. Since you did switch x and y, solve for y, this now is your inverse function, and it's designated over here f to the -1 over x, where the -1 is not an exponent, it's designating inverse function, and your answer is x plus 5 over 3. Here, question 25, we have a vector diagram, and we need to carefully, if you notice on your paper, all of this writing isn't there. You just see this outer triangle here. So we need to look through the information. So O is the origin, and OP, which is down here, O to P, first of all, is called vector P. So OP is vector P, and OP is twice OA. So if OP is twice OA, then that means A is the midpoint. And if OP is vector P, then OA is half P and AP is also half P. Also, we get OQ, O to Q is vector Q, and 3OB, or OQ is equal to 3 times OB. So if you have OB, OB, and OB, that gives you your Q. So that means OB is 1/3 Q, and that means B to Q has 2 OBs. That means it's 2/3 of Q. So you kind of have to figure out these little ratios here in terms of your vectors P and Q. And then it also says that PM is equal to MQ, meaning again that M is the midpoint. So these two sides over here are equal or congruent. Now that we have all that put out onto our diagram, now we can start figuring out these questions. Find in terms of P and Q in its simplest form, vector B to A. So we want to go from B to A. Notice that would be, notice that OB and OA are tail to tail. So if you have tail to tail and you're connecting the heads, it's subtraction, end minus start. So OA minus OB. So you have a vector B to A connecting OA and OB. These are tail to tail, so you subtract end. Here's the end of the vector, OA minus start. Here's the start of the vector OB. So BA equals OA minus OB. And so you get half P minus 1/3 Q. So it's a little easier if you start off with a formula using the big letters so you can see where you're going, then fill in your P and Q parts to get your answer. Now down here, find position vector of M. Position vector means from the origin. So from the origin to M, so we're going to want to go from O to P and P to M. So notice OM equals OP plus PM. Well, we have OP, which is vector P. So that part is easy. You follow it down, OP, 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 you get to P is the substitution there. That's easy. But what about PM? Well, PM is half of PQ. Okay, so we start off with that. PM is half of PQ. Well, now what is PQ? PQ is the end of this one here. From P to Q is OQ minus OP. So notice OQ minus OP is PQ. Okay, OP minus its end, OQ minus start, OP. End minus start. And our OQ is Q and our OP is vector P. So now we have everything in P's and Q's. So distribute the 1/2 Q minus 1/2 P. P minus half P is half Q plus half Q. That is the position vector of M, 1/2 P plus 1/2 Q. Now for velocity time graph. So in our velocity time graph, says a car is traveling at 20 meters per second for 15 seconds before it decelerates to a rest, decelerating at 2.5 meters per second, which by the way is your slope. Find the total distance traveled. Remember, total distance in a velocity time graph is area, because when you multiply time by speed, the seconds cancel and you get distance. So we want area of this graph here. So I broke it up into a rectangle and a triangle. So for the rectangle part, that is the distance or the area underneath section 1 here. It's just a rectangle. So length times width, 20 times 15 is 300 meters. Then we need to find the area of the triangle, but we don't know the endpoint. So we need to calculate this endpoint first. How far did it travel as it's decelerating, or how many seconds did it take to decelerate? So we're going to use this velocity formula where final velocity, because it comes to a rest, so our final velocity is equal to our initial velocity plus acceleration times time. So V equals U plus AT, V being the final velocity equals U being your initial velocity plus A. Our acceleration is a negative 2.5 because it is decelerating. So that means that it's a negative acceleration, negative 2.5 times T. So we add the 2.5 to T to the other side. Divide by 2.5, it means it took 8 seconds for it to go from 20 meters per second to 0 meters per second. So if you go 8 seconds from 15, that means you end up at 23 seconds. Now we have our triangle, half base times height. Remember the base is actually 8 and the height is 20. So 1/2 base times height gives us a total of 80 meters plus the 300 is a total of 380 meters. And that is the end of this winter or October, November 2019 paper 21. I hope that helps you, and I hope to see you again next time on Quick Fix.